Join me in welcoming Sohaila Diab, data scientist at Bayesianx, as she presents her technical talk titled Let's Talk GenAI. I hope I pronounced that right.
Thank you. Hello, everyone. I hope you're having a great afternoon. I'm Sohaila. I am working as a data scientist mainly with generative AI and NLP and automation. But don't worry, not taking anyone's job here. We will discuss this later. And as mentioned, I'll be talking about generative AI. So before we get started, I have a question for you guys. When did generative AI become a thing? Like when did the concept become a thing? Does anyone have an approximate year?
Repeat the question again.
What year did generative AI, the concept of generative AI, become a thing? No guesses? A couple of years ago? All right. So actually, generative AI, the concept has been around for quite a while. Back in the 1960s, in MIT, a professor called Joseph Melbourne, hope I'm pronouncing it correct, he made a chatbot called Elisa. And actually, this chatbot was working. You give it the questions, and it gives you an answer. And it was a very simple algorithm, not as good as we have now, but it was still, the concept is still out there. So what happened? Why is everyone talking about generative AI now? And it's all the hype now. It's all what's everyone been talking about. As you can see here, ChatGPT reached 100 million users in only 2 months, compared to other platforms that took years to reach 100 million users. And this is because this is something new to the general users. And the average user doesn't really interact with AI, so it was something very new. Oh, when I type something, it gives me an answer, and it's sometimes correct. And it was something very new, so it excited people. So next, we'll be talking about what is generative AI. I'm going to break it up into 2 bits, generative and artificial intelligence. Starting with artificial intelligence, it's basically machines that can perform human tasks. It mimics the human intelligence. And to give you some examples of what is being used in AI now, it's a huge field, so maybe something like predicting house prices, given some data about the house, maybe the number of rooms, it can be able to tell you what's the house price. And something more complex is in autonomous cars. When the car is going, it can be able to detect if there is a pedestrian, if there is an object in front of it. So it's a huge field. So what is generative, and what does generative add to it? It gives it the ability to create things. It creates content like text or image, and sometimes even video. And it is not being explicitly programmed to do so. And this is new. Now AI is not just an executor. You can somewhat say it's an inventor. So how does it work? I'll be talking here more about generative language models, which is focused more, it's kind of like GPT, and basically an outline of how it works is that you will start by giving it a large amount of data. This is the model. You start giving it a large amount of data, corpus of data, as you call it. And this data is like huge, like all the articles on Wikipedia, everything on Twitter, and so on. You give it a lot of data. And then you truncate, and the language model predicts the next word. And by this, it means, for example, you will take a sentence, remove the last word, for example, and the model predicts what is the possibility of that word being something, the next word. So it continues the word. And then it keeps improving itself. It goes through the corpus, and it keeps training and training to improve itself. And yeah, this is an iterative thing that it goes through. So we'll talk more about the model. So we'll first imagine it as a black box. And as I mentioned, given a sequence of words, it predicts the next word. So let's say the sky is, obviously, the answer would be blue. So it would predict that the sky is blue because it thinks that this is the most probable answer that it is. So this is kind of like how it works. So basically, like ChatGPT, as you could have seen here, it creates word after word. So it takes a sequence of word and then keeps creating the word and the word after it and so on. So what is inside this mystery box? And like, what exactly is this? How does it know blue is the right answer? And let's open up the mystery box and have something called neural networks. And as you can see here, it said that blue has a 71% chance of being the right answer. So what exactly are neural networks? So to give you an overview of neural networks, they are actually inspired by the human brain. We have something, as you can see on your left, the top left, we have something called the neuron, which is something in our brains, and it is inspired by it. So each of these circles, it's called a neuron, and it represents the neuron at the top. It takes in an input, does some mathematical functions, a mathematical equation, and gives an output. So it can take in things like text, images, or even audio, and so on. However, it takes it as a number. So it needs to first convert it into a number. We need to convert it into a number. So for example, we have an image. We won't just give it the image. It will take the pixel values of the image. And then it gives out some number. And then that number can be converted into the text, image, or audio, depending on what we want. So I just want to let you know, so basically this neural network is like a connection of neurons. So as you can see, like the first two, these are the inputs, the first two neurons and the inputs, and it goes through something called the hidden layers, and these are basically just the neurons in the middle. And at the end, it goes through the output layers. So I just want to let you know that these are connected to each other. So these connected to each other, and the way it learns is that each connection, it carries something called weights. And these weights are basically parameters. And these are something that the model uses to learn to give us the output. So how many weights do we have here? We have about 42 weights. So we have 42 trainable parameters. We have 42 connections that the model needs to learn. So I'm telling you this, I want you to remember the number 42 for something later on in the presentation. So this is very small, so we don't really use this in generative AI, this model. It's very simple. We actually use this big monster here, the transformer, and it came out in 2017, and it was a huge game changer. It came out in a paper called Attention is All You Need. Maybe, probably a lot of you might have heard of it. And it was a huge, huge game changer. It changed everything. And it sped up the processing time. It let the model be able to learn the context better. So no matter what the distance between the words is, or the words are, it will be able to learn the context of it. So don't worry, I won't go much into the details of it, but I just wanted to let you know that the transformer is something that we use. So actually the T here, the transformer here is actually the T in ChatGPT. So it uses the transformer model. And these are basically, it also works with, it's a type of neural networks. It works with neural networks. So now that we have the model and it's trained, we have the weights, like we said, we have the parameters and it's already trained. And it's trained on so many data. How can we make use of it? We have something called pre-training and fine-tuning. And basically what we do is we train the model. This is something called pre-training, is that we train the model, like I mentioned before, we give it a huge amount of data, it trains it, it fixes the weights, it remembers the patterns that we have, and it's trained on a lot of data and a diverse data. So Nothing specific, so let's say it's trained on all the data on Wikipedia, so nothing very specific. And we wanted to do something specific because this might be a well-rounded model, okay, but it's not specialized in something. So it's kind of like when you go to a doctor that is specialized, not a doctor that is well-rounded in a certain thing that's okay, so-and-so and something. So we want to make it specialized, we want to make it for something specific. So we have something called fine-tuning, and basically what we do is that we take this model here, the model that we have that has been, the huge model that has been already trained, and give it some specific data. We train it on more data that is specific to our needs. So let's say we want it to be, we want a medical chatbot. We will train it on medical data. And here we freeze the parameters, and then we retrain it, and maybe we can leave out the last layer, the output layer to be able to change some parameters here. So this is fine-tuning. Basically is that we want to train it on a specific task. So this is kind of like a use case. So I asked ChatGPT, my stomach hurts, and what it gave me is that, stomach pain can be something from you ate something, or it could be something serious. So maybe if it persists, go seek medical care, or maybe you can just drink tea or something. And this is terrible advice. Imagine telling the doctor, I have a stomachache, and the doctor tells you go drink some tea. This is not what we want. So we pre-trained, actually there's something called Chat Doctor, and this is a model that actually some people worked on. They fine-tuned a generative language model, and they gave it medical data. And the answer that it gave to this question is that it's much more specific. So it says if the pain is in the upper part of the abdomen, it could be this and this, and some other details about it. And then at the end, it tells you that it hasn't even seen your reports, so provide more details about it. So this is very useful So this is very useful to be able to train your model to be more specific, to be good at something. So what gives generative language models more power? What makes them better? Weights or parameters, as we have here. The number that I told you to remember before, 42, this very tiny neural network. Can you imagine, has anyone used GPT-4 or ChatGPT-4? And so this ChatGPT-4 is trained on, or has 1.76 trillion parameters. So you can imagine how big this model is compared to the 46 parameters that we just saw. So you can imagine how huge it is, the number of computations that it needs. It is enormous. And this is, it's much more complex than the rat brain. It's much more complex than the ant brain. Not as complex yet as the human brain. The human brain has 100 trillion. We still don't know if it's ever going to reach that, because the human brain, we don't fully understand it yet, right? So it is improving. From GPT-3, I think it had about 100 billion, I think. Yeah, 175 billion. So it went from 175 billion to 1.76 trillion. So it's improving fast. And this gives it more power. It gives it more space to learn more things, to train on more data, to learn more complex tasks. Another thing is the data that is trained on. So as you can see here, the average human has seen have seen about 1 billion words in their lifetime. Compared to GPT-4, it is enormous. So GPT-4 is trained on so much data. And it's much more than English Wikipedia, and it's almost reaching all the human written text. And this question actually, this is very, very expensive. You can imagine how expensive this is. Reportedly, training GPT-4 took about was about $100 million to train it, and this was very, very expensive. And also something interesting here is that even though we're exposed to much less words in our lifetime, much less data, but we learn much, much, much faster than these models. They take so much more to learn. Babies even learn faster. So this is something they're amazing in our brain, of how our brain works. So next, we have the ethical considerations and risks of AI. So what can you see here? So this is actually a model was asked, a text-to-image model was asked to give representations of people working in certain occupations. So for each occupation that we have here, there were 300 faces generated, and these 300 faces were, averaged into one. So each face you see here is actually an average of 300 faces. And what do you notice here from the high-paying occupations and the low-paying occupations? Is that the high-paying occupations, the model predicted that most of these are actually men, and most of them, or all of them actually are light-skinned. However, for the low-paying occupations, most of them are women, and most of them are dark-skinned. So this is bad, and this means that the model thinks that some jobs are more suitable for people than the others, right? So so many risks rise with this. Like, for example, if it's trained, this is because of the data that is trained on. It gives it bias. The data that is trained on maybe had more people, white-skinned people working on the high-payer occupations, which is not necessarily correct. So this is an issue that we have. And has anyone here heard of AI? No one? So this is actually a Twitter bot made by Microsoft. And this Twitter bot was basically, they put it out, and it was trained on, it's supposed to learn from the tweets that people send. So can you imagine, it's trained on Twitter, and this is terrible. Who would train it on Twitter? This product here, or this account here, was closed after 16 hours. They shut it down after 16 hours. Why? Because of the data that is trained on Twitter. This bot became racist. It swore a lot. I won't show what it said, but it was terrible, so they had to shut it down. And Microsoft here did not put, a barrier on what things to learn from, right? It did not take this into consideration. It did not take into consideration that it's going to, be exposed to bad data, so it did not stop it from learning from it. So they shut it down, and this is an example of harmful content. Next is hallucinations, and as you can see here, ChatGPT is a liar sometimes. So I gave it 3 statements, and like one of them, I said which one of them is correct. The CEO of OpenAI is Elon, or there are 2,000 people living on Earth, or Google acquired Microsoft in 2002. Some very, very random facts. And it told me that the statement that there is 2,000 people living on Earth is true. This is absolutely false. There are not even 2,000 people living on Cairo. It's much more. So here it is lying. It's outright lying. So this is also why you should not fully trust these chatbots. You're not